Hello guys, this is type 1 of numericals which are based on work energy, power, and these are from work done by the constant force. So in this question there is a block of mass 20 kg which is being slowly pushed up a inclined plane of inclination 53 degree by two type of forces. One force is acting on this block in such a way such that this force is parallel to the inclined plane. This is F, which is applied to push this block, and this angle is 53 degree. So this force, we have to find out the work done in displacing this block up the incline by a distance of 4 meters. Okay, now we can say that if this force is displacing this block slowly, then it means that acceleration of the block is zero, and it also means that net force on this block is zero. So the force which is acting in the downward direction is mg sine 53, and this force mg sine 53 is being balanced by F, so that block has no net force acting on it. Therefore we can say that this F is equal to mg sine 53, and mg is 200 and sine 53 is 4 by 5, which is equal to 160 newtons. Now the displacement in the direction of force is 4 meters. So the work done will be plus 640 joules, which is the product of 160 and 4. So this is the work done in first case. Now in second case, this force is being applied this is 53. Now in this case, this force is applied like that in the horizontal direction. So the component of this force in the direction parallel to the inclined plane, like that, will be F parallel, and F parallel will be F cos 53. Now we know that work done is always the product of that force and displacement which are parallel to each other. So this F parallel is being multiplied by 4 meters, which is the displacement along the inclined plane. This is 4 meters, and this work done will be hence equal to F cos 53 into that 4 meters. Now this F cos 53 will be balancing mg sine 53, because again in this case again the block is being displaced slowly, which means that the force acting in the downward direction this force mg sine 53 is being balanced by F parallel. So work done will be equal to mg sine 53 into 4, which is again equal to 640 joules. So in both cases the work done is same. Now we move on the next question. In this question there is a block which is placed on a horizontal surface which is also rough. and a force F is displacing this block with the velocity v, constant velocity v, and the mass of block is m. Mg will be acting in the downward direction and normal reaction will be acting in the upward direction. Now, due to the fact that this block is moving with constant velocity, its acceleration will be 0, and hence the net force acting on this block will be 0. So if we wonder that which force is balancing this F, then the answer will be the friction, which would be acting in the backward direction, and the friction force will also be equal to F, because the magnitude of both forces must be equal and their direction must be opposite so as to cancel out the net force. So in time t, the displacement of the block will be Vt, and the work done by the weight of the block, first case, work done by mg will be 0, because the angle between force mg and displacement is 90 degree. Similarly, the work done by normal reaction will also be 0, because this angle is also 90 degree. Now the C part, the work done by friction. Now you can see that friction is acting in the reverse direction and block is being displaced in the forward direction. So work done by the friction would be given by F into S into cos 180 degree. So work done by the friction is equal to F, which is capital F, S is Vt, and cos 180 is negative. So this is the work done. And next D part is also the work done by force F. So work done by capital F will be F into S into cos 0 degree, and it would be F into Vt into cos 0 is 1. Now the value of F is equal to friction, and friction acting on this block will be mu mg, the maximum possible value of friction. So if we keep this value in options C and D, we will get in this minus mu mg Vt, and this will be plus mu mg Vt. Now we move on the next question. In this question, a force which is given in vector form as 4i cap plus j cap plus 3k cap newtons, and this force is displacing a particle from its position r1 to position r2. Now we need to find out the work done by this force. So first of all, the force given in the vector form will be 4i cap plus j cap plus 3k cap, and the displacement in the vector form. Now I am talking about the displacement, and these r1 and r2 are the position vectors. r1 is the initial position vector and r2 is the initial final position vector. So the displacement will be the final position vector minus the initial position vector. So it would be r2 minus r1. So 14 minus 3 will be 11 i cap, plus 13 minus 2 will be 11 j cap, and 9 minus of minus 6 will be plus 15 k cap. So the work done in this case will be simply F dot S. So work done will be equal to 4 into 11, 44, plus 11 plus this 45. So this is 100 joules. So the correct option will be option number A. Now we move on the next question. In this question, there is a block of mass 0.3 kg, and we are sliding this block up the inclined plane slowly. So the length of the inclined plane is 10 meters, which is the hypotenuse, and the height of the inclined plane is 5 meters. So this is 5, and this length is 10. Now in first case, we are making it move in the upward direction slowly, which means that in upward journey, the net acceleration of the block is 0 and the net force of the block is 0. So the applied force on the block will be balancing friction plus mg sine theta, where theta is this angle of inclination. Now friction F will be equal to mu mg cos theta, and theta, we can say that sine theta is equal to perpendicular upon hypotenuse. So perpendicular is 5, hypotenuse is 10, sine theta is half. Therefore theta is 30 degree, and cos 30 degree will be equal to root 3 upon 2. So in the upward journey, we are making it slide upward slowly, and the force is applied parallel to the inclined plane, and then we are allowing it to slide down to the bottom again. Now the coefficient of friction is given as mu is given as 0.15. Therefore the friction will be 0.15 into m, which is 0.3, 0.3 into g, which is 10, and cos theta is root 3 by 2. Now you can calculate easily the value of friction from this equation, and we need to find out the work done by gravity in the round trip. So work done by mg in upward motion, So in the upward motion, mg will be acting in the downward direction, and block will be moving in the upward direction by a distance of 5 meters. So the work done will be minus mg into 5, and work done by mg in downward motion will be plus mg into 5, because in downward motion mg will be acting in downward direction, as well as the displacement will be in the downward directions. So net work done by mg in round trip will be 0. So this is the answer of option number A. Now work done by the applied force over the upward journey. So in upward journey, applied force, as we have already calculated, applied force is mg sine theta plus F. Now we have calculated the value of friction, we have calculated the value of sine theta also. So by placing these values here in this equation, we can get the value of applied force. This is the applied force, and hence the work done by the applied force in upward journey will be F into 10, which is the displacement in the direction of the force, because force is acting parallel to the displacement. And for option number C, the work done by friction over the round trip. So for C option, as friction will be acting in the downward direction and block will be displaced in upward direction for the upward journey, therefore work done by friction will be equal to the work done in upward journey plus work done in the downward journey. So it will be equal to, the work done in upward journey will be equal to minus F into 10, because friction is acting in the downward direction and displacement is along the incline in upward direction. And also in the downward motion, the friction will be acting in the reverse direction of the motion. Hence, the friction will be acting in the upward direction of the incline, and displacement will be down the incline. So again, it would be a negative sign, minus F into 10. So the net work done by the friction in the round trip will be minus F into 20. So this was the easy one. Now we move on to the next question. In this video, we can it is given that there is a block of mass m which is connected with a rope to the roof of a elevator. The elevator is going up with an acceleration of a, and we need to find out the work done by this tension force on this block in time t. So first of all, we need to find out the tension force. So the tension force will be equal to mg plus ma, because in the frame of the lift, pseudo force will also be acting on the block. So tension will be equal to mg plus ma. And the displacement of this block along with the lift in time t. So in time t, S is equal to 0 plus half a t square, where 0 is the initial velocity. So S is equal to half a t square. Now the work done will be equal to plus t into S, and S is t is equal to m g plus a, and S is equal to half a t square. So this is the correct answer, which is option number A. Now we move on to the next question. In this question, you can see that there are two blocks, and that 20 kg block is being kept over this 30 kg block. The friction coefficient between 20 and 30 kg is 0.5, and the floor on which this 30 kg block is kept is frictionless. A force of 50 Newton is applied on this 30 kg block, and we need to find out the work done by the friction force on the upper block in 2 seconds. For that, first of all, we need to find out magnitude of the friction force which will act between these blocks, as well as the displacement of the upper block in 2 seconds. So to find out the magnitude of the friction force, we need to verify that whether they will slip on each other or they will move together. And for that, as we have already studied in friction, that we need to assume them as a system. So assuming them as a system, the acceleration of system will be 50, which is the external force, and upon 50, which is the total mass of the system. So this is equal to 1 meters per second square. Now we need to jump over this 30 kg block, and we need to draw the free body diagram of this 20 kg block, because we need to go in the reference of frame of reference of that block on which the external force is applied. So external force is applied on 30 kg block, so we need to go in the frame of reference of 30 kg block. So with respect to 30 kg block, the FBD of 20 kg block. So this is 20 kg block, and the pseudo force will be acting on this block in the reverse direction, which is F is equal to MA, and M is 20 and A of the system is 1. So F is equal to 20 newtons, and the frictional force, which maximum friction which can act on this block, is equal to mu mg. Here mu is 1 by 2, mg is 20 into 10. So it is equal to 100 newtons. So you can see that this maximum friction is sufficient enough to balance the pseudo force, and F max is greater than pseudo force, which means that there will be no slipping will occur, and the friction which will act actually will be equal to the pseudo force, because that much friction is only required. So the acting friction will be 20 Newton, and these blocks will be moving together. So the acceleration of the system will be the acceleration of these individual blocks also, and hence the displacement in 2 seconds, displacement of this 20 kg block, S is equal to ut, u is 0 plus half, a is 1 and time is 2, so it is 4, so S will be equal to 2 meters, and the work done will be equal to force into displacement, F into S. So work done by the friction force on the upper block will be 20 into 2. So work done will be 40 joules. There is an interesting fact that the work done by friction force on 30 kg will be equal to minus 40 joule, and you can calculate that if the 30 kg block is also moving with the same acceleration in the forward direction, so its displacement would be same as 2 meter, but the friction acting on 30 kg block will be in the reverse direction. So the work done on that 30 kg block will be negative 40. So you need to remember one thing, that in these kind of questions in which block is placed over the block, and when there is no slipping occurring between the blocks and they are moving together as a system, then the work done by that internal friction which is acting between these blocks it will be 0 for complete system. For individual blocks, that work done would be equal in magnitude and opposite in sign, but for the system of the two blocks, that work done by this friction will be 0. Okay, now we move on the next question. In this question, the system is shown in the figure, and the friction coefficient between the blocks is mu, but this floor is frictionless, and the force F is being applied on the lower block. The mass of these two blocks are same, and the upper block slips over the lower block. It is given in the question that there is a relative motion between A and B. So in some duration of time, this lower block moves a distance of L in the forward direction, and we need to match the following options correctly. So we know a fact that acceleration of B, and this is acceleration of A, and acceleration of B will be greater than acceleration of A, because when this force is being applied on the lower block, the upper block cannot move faster than the lower block. Now the first thing is the acceleration of B is greater than the acceleration of A. So we can say that the displacement of B in some period of time is L, then in the same period of time the displacement of A will be less than L, obviously because the acceleration of A is less than the acceleration of B. Now the friction force acting on A will be in the forward direction. This is the block A, and the friction force acting on A will be in the forward direction, and the displacement of A will also be in the forward direction, which is SA. Now the value of friction will be mu mg, because sliding is occurring and friction will be acting to its peak value. and therefore work done by friction on A will be positive, you can see that, and will be F into SA, which is less than mu mgl, because SA is less than L. So the work done by friction on block A is positive, which is option number P, and it is also less than mu mgl in magnitude, which is option number R. Now work done by the friction force on block B. So on block B, the friction is acting in the reverse direction, in the backward direction, because the friction applied by B on A is in forward direction. Therefore friction of A on B will be in reverse direction, and the displacement of B is given to us as L, and therefore we can say that the work done by friction on block B will be negative, which is option number Q, and its magnitude will be equal to mu mgl. So it is option number S. Now for option number C, the work done by friction on A plus work done on friction on B is, now we know that the positive work done, this is the positive work done, let's suppose it is W1, and the work done by friction on B is equal to negative of mu mgl. Let's suppose it is W2. So if we add W1 and W2, in which we know that W1 is less than W2 in magnitude. So if we add these two, the complete work done will be negative. Hence, for option number C, the correct option will be option number Q, and the total complete work done will be less than mu mgl in magnitude, which is option number R. Now for the last option, work done by force F on block B will be positive, as F is applied in the direction of motion, and the magnitude of this work done would be mu into, no, it would be F into L, which is not given in any of the options. So the correct answer will only be the option number P. Thank you. In this question, there is a elevator. You can see this elevator, and there is an inclined plane which is kept in the elevator like that. This angle is theta, and there is a block which is kept on this elevator, and this elevator is going down with the uniform velocity of v. So this block is not moving with respect to elevator, which means that this mg sin theta is balanced by the friction acting on the block. So the friction will be acting in the upward direction, and this mg sin theta will be acting in the downward direction. So F is equal to mg sin theta, because net force acting on this block is 0, and the velocity of the block is in downward direction with respect to ground. Therefore the displacement of the block with respect to ground will be Vt in time t. Now we need to find out the work done. So to calculate the work done, I can see that the friction force is acting like that, and the velocity is in this direction, and the angle between these two, I can draw the angle. This angle is theta, and this angle will be 90 minus theta, and therefore this angle will be 90 plus theta, this is friction and this is displacement S. So the work done will be F into S into cos 90 plus theta. Now cos 90 plus theta will be minus sin theta in the second quadrant. So it is minus F is equal to mg sin theta into S is equal to Vt, and this is sin theta. Minus we have already used. So work done will be minus mg sin square theta into Vt. So this is the option number C. Now we move on the next question. In this question, there is no friction between the ground and block B, and the friction coefficient between A and B is given as 2/3. We need to check out these four options. So first of all, we are verifying that whether they are slipping on each other or not, and for that I am finding out the acceleration of the system. So the acceleration of the system will be mg, which is external force upon 3m. So it would be g/3. And if I need to examine the slipping, I am drawing the FBD of block A with respect to B. So pseudo force will be acting on this block in backward direction, which is equal to MA, and the friction that can act on this block is F max in the front direction. Now this MA pseudo force is equal to mg upon 3, and the maximum friction which can act is equal to mu mg. So F max is equal to mu is 2/3 mg. So I can say that F max is greater than pseudo force. So friction is sufficient to prevent the slipping between the blocks, and therefore there will be no slipping. So they will move together, and hence the acceleration which I have calculated as g/3 will be the individual accelerations of these blocks also. Now the net work done on the block A with respect to B will be 0 is the correct option, because with respect to B, A is not being displaced and A and B are moving together with respect to ground. Therefore, for any observer which is standing on block B will see the block A as stationary. Therefore, he will say that the net work done on A will be 0 with respect to B. Now the option number B, the net work done on A with respect to ground for a displacement of S will be mgs/3. Now we can say that if F max is greater than pseudo force, then friction is sufficient to balance the pseudo force, and hence there will be no requirement of this much friction, and the friction which would be acting actually will be equal to pseudo force, and that would be mg/3. So this friction will be actually acting on these blocks, between these blocks. So the work done on block A will be friction force, this F work done on A with respect to ground will be equal to this friction force into displacement S. So mgs/3. So the option number B will be correct option. Now for option number C, the net work done on block B with respect to ground for a displacement of S is this. So we need to calculate the net work done, and net work done will be the work done, sum of the work done of F and friction. Now work done on B with respect to ground by friction F. Now friction will be acting on block B in the backward direction, and its displacement is in forward direction. So its work done will be minus F into S, and work done on B with respect to ground by F will be equal to F plus F into S, because F and S are in the same direction. Now this F is equal to mg, and therefore it is mgs, and this friction will be equal to mg by 3 and into S. So the total work done on block B will be equal to sum of these work done, and it would be equal to 2 by 3 mgs, which is the option number C. So it is the correct option. And for option number D, the work done by friction with respect to ground on A and B is equal and opposite in sign. So we have already discussed this fact in previous question, that in the case when there is no slipping between these blocks, then the work done by the friction with respect to ground on these blocks will be equal in magnitude and opposite in sign. So the D option will also be correct. Now I move on the next question. In this question, there is a man who is applying a force F, pulling force F on this spring as shown, and this spring is connected to this compartment in which the man is standing, and this compartment is moving with a velocity v in this left hand side. So in time t, that compartment covers a distance of L, and we need to examine these four options. Now first of all, I can see that this man will be pulled by the spring in the front direction also, by the same force F which this man is applying on the spring, and then also this man is not slipping on the cart, so there would be a friction force which will be acting on the man in the backward direction, whose magnitude will be equal to F. Now the man acting with the force F on the spring does a work done of W is equal to minus FL. So we need to find out the work done by the man on the spring. So this spring along with the cart will move in a left direction by a distance of L, and this man is pulling this spring in the direction of right hand side direction. So the work done by the man on this cart will be minus, and it would be F into L. Okay, because the force applied by the man on the spring is towards right hand side, and the displacement of this spring is towards left hand side. The total work done performed by the man on the compartment and the spring with respect to ground is 0. So a man is experiencing a force of spring pull towards right hand side and towards left hand side, and the man is experiencing a friction force towards right hand side. But if I draw the free body diagram of the compartment, then this man is applying a force on the compartment F in this direction, and he is applying a reaction force by his foot in this direction, which is the reaction of friction. So the net force applied by this man on this compartment will be 0, and obviously this compartment is also moving with a constant velocity. So the total work done will be 0. So option number B will also be correct. Work done by the friction acting on the man with respect to the ground is minus F into L. So friction is acting on this man in the reverse direction, and the man is going in the forward direction, and the distance covered by the man in time t will be L. So C option is also correct. Now option number D. The total work done by the man with respect to ground is minus F into L. This is a wrong option because we have already discussed that option number B is correct. Now we move on the next question. In this question, there is an inclined plane and a block of mass 4 kg is kept on this inclined plane. Now the angle of inclination of the inclined plane is 53 degree, and a force of 40 Newton is also acting on this block in the downward direction, and a block is moving with an acceleration of 10 meters per second square in the downward direction. It is given in the question. This is 10. And this is the mg sine 53, mg sine theta, will be acting in the downward direction, as well as this F, which is 40 Newton, will be acting in the downward direction, but the friction will be acting on this block in the reverse direction, F. Now we need to find out the displacement of the block in 2 seconds. So in 2 seconds, S will be equal to ut plus half at square, and S will be equal to u is 0 plus half a is 10 and t square will be 4. So this will be equal to 20 meters, the displacement of block in 2 seconds. And we need to find out the work done by the applied force in 2 seconds. So first of all, we are concerned with the fact that the direction of applied force is not given in the downward direction. In fact, I have assumed it to be in the downward direction, but I need to examine that whether it is acting in downward direction or in upward direction. So I can see that the value of mg sine theta is equal to 40 into sine 53 is 4 by 5. So this is equal to 32 newtons. Okay. Now the value of friction, F max, because sliding is occurring, therefore friction will be acting to its peak value. It would be mu mg cos theta. The value of mu, the value of mu is not given to us. So if the mu is not given, then it is sure that this force will be acting down the incline. So we cannot verify that the direction of this force, because to verify the direction of this force, the value of friction must be given in the question, and it is not given, so we are assuming that this force is acting in the downward direction. So if this force is acting in the downward direction, then the work done by this force will be F into S, and S is 20, F is 40. So work done by this force will be that 800 joules, because W will be equal to 40 into 20. Now the work done by the weight of the block in 2 seconds starting from the starting of motion. So weight is mg sine 53, which is 32 newtons, and the displacement is 20 meters. So work done by mg will be mg sine theta into s, and this will be 32 into 20, so it will be 640 joules with a positive sign. So the correct answer will be option number C. Now for the third question, we can say that the force is applied in the downward direction, mg sine theta is acting in the downward direction, and friction is acting in the upward direction, and the block is accelerating in the downward direction. So to calculate the value of friction, I am writing the equation that F plus mg sine theta minus friction is equal to ma, and the value of F is 40, mg sine theta is 32, minus friction is equal to m is 4 and a is 10. So friction is also equal to 32 newtons. We have calculated the value of friction. Now the work done by friction will be negative, because friction is acting up the incline and block is sliding down the incline. So it would be minus and F into S. So it is minus 32 and into 20, which is the displacement. So the answer will be minus 640 joules, which is the option number D. Now we move on the next question.